Alright, hello, my name is Casey Shibler, and I am doing a reassessment video on the properties of materials standard. The first question I'm going to cover is an electron and a neutral carbon atom are initially, 1 times 10 to the negative 6 meters apart, and there are no other particles in the vicinity. The polarizability of the carbon atom has been measured to be this one, and then it says calculate the initial magnitude and direction of the acceleration of the electron. So that's what I've done over here. I have drawn out my figure, and I have the mass of an electron is 9.1 times 10 to the negative 31st. I have my constant of polarizability. I plug that in. I have F is equal to 1 over 4 pi epsilon naught squared times 2 times alpha, the charge squared over r to the 5th. F is also equal to ma, so I could just rearrange that and have A is equal to F divided by the mass. So that gives me A is equal to 1 over 4 pi epsilon naught squared times 2 alpha times the charge squared over the mass times r to the 5th. Then I plug everything given to me in, and I get the acceleration is equal to 893 meters per second squared. It then asked, what if the distance between the electron and the carbon double? So what I would do is I have my acceleration equation, and I just doubled the r. So whenever you actually multiply that out, you get 1 over 2 to the 5th, which is 1 over 32. So the initial acceleration would actually be 1 over 32, or of a fraction smaller, due to that. The second question is a point charge of 3 times 10 to the negative 9th coulomb is located at an origin, as denoted up there. It then asks, what is the magnitude of the electric field located at 0.200? So what I did is I have my charge that was given to me, which is located here. They want to know the magnitude of the electric field here. So I have my new r is equal to the observation minus the source. I have figured out my r hat through these various steps, and then I use my electric field's location. Oops, that's a 5. And I work everything out to get 675 newtons per coulomb. Thank you very much. Now, let's say that a metal rod was placed here. A metal rod's a conductor and will basically be its own dipole. Have its own dipole. The net charge of a dipole is 0 the net electric field of a dipole moment is 0. So whenever placed here, it'll actually increase the electric field here. That's all I have at the moment. Thank you very much.